Hello everyone and welcome. We're here to talk about automated UI testing, but hopefully the right way of doing it. For those who don't know me, my name is Mehdi Khalili. By day, I'm a senior developer at Redify. I code, design, mentor, lead teams. By night, I'm a open source developer. I've got a few active open source projects that I work on. I blog here. That's my email address and my Twitter account down the bottom. Before I start, I should mention that things that we're talking about here are not necessarily new. These ideas and patterns aren't necessarily new. We're going to be talking about a lot of ideas that have been being used by professional developers and testers for years and years. So these are framework agnostic ideas and patterns. So regardless of the UI technology that you're using or UI testing framework that you're using, you can apply the very same ideas and patterns. So I use the very same ideas and patterns, even though I'm going to be talking about web testing. I use these ideas and patterns to test a WPF application using coded UI test. That said, for this talk, we're going to be using a few specific frameworks. We're going to be using Selenium. Has anyone here used Selenium before? Oh, that's good. Quite a few. That's awesome. So Selenium is an open source project. Lately, it merged with another web testing framework called WebDriver, and now it's available from NuGet on this package here. The other framework that I'm going to be using is called BDD. 2 years ago, I had an idea about making a BDD framework that's very simple to use. No requirements for using a base class or attribute or no dependency on any testing framework, no nothing. We just use this framework, abide by some conventions, and it just works. BDD was recently moved to GitHub, and it's now part of a bigger testing family called TestStack. It is available from NuGet as a package that you can install, teststack.bdd. The other framework that we're going to be using is called Selenium in this talk. One of the very early adapters of BDD is a guy called Michael Whelan from London, and he kept asking me questions about how he can kind of use BDD to do automated UI testing with Selenium. And we kind of got sidetracked after those discussions and started talking about Selenium and how we can actually do Selenium better and write more maintainable UI tests. We used those ideas and patterns in a few personal and work projects, and then we decided to turn those into something that can be used by the community, so not everyone has to go through the same level of pain we went through. So Selenium was created like 2 months ago, and it's now part of the same TestStack family on GitHub. The source code is there, and you can install it as a NuGet package as well. The samples that we're going to be showing in this talk are all part of the Selenium code base. So you can download them from GitHub on the Selenium code base, and that's going to make it simpler to kind of make sense of what I'm talking about here. So why UI testing is a likely failure? 2 years ago, I was very skeptical about UI testing. I had some exposure to UI testing, but every time I tried UI testing, it turned out to be a disaster. I would have started, and I think a lot of teams kind of share the same experience with me. A lot of teams start with a great UI testing experience. They write a few UI testing for the first week. After a month, they've got like 20. It covers a lot of their stories, and everything is happy, and everyone is happy that they've got some sort of good test coverage. And then the code changes, the requirement changes, and you change something, and all of a sudden you end up with half your tests broken. And the tests are not broken because the logic has changed necessarily. The tests are broken all because of the wrong reason. Like you change a label on your page, the logic hasn't changed, but your test breaks. That makes it really unmaintainable, and you end up spending a lot of times, day by day, maintaining your test suite. And after a while, you may actually fail at it and say, that's it, I'm fed up with this. I've spent like 3 hours a day for the past 2 months maintaining something and that's not necessarily delivering the value that I expected. Anyone sharing that experience here? That's good. So we may have a few things to talk about here. And this is basically my experience. That's exactly the same thing that's happened to me in the past. And the reality is that the UI tests are hard to write. they are very hard also to maintain because you're doing an end-to-end test, and a lot of things could go wrong when you're doing something like that. If your network is down, if your database is down, if your file system is inaccessible, if your UI layout changes. So a lot of things are there, a lot of criteria should be met before a UI test is passing. So they're very hard to maintain because they break for a lot of reasons. And they're also very brittle because UI testing relies on the UI, and UI is the thing that changes the most in a lot of applications. So you've got a very high likelihood of breaking something because the UI has changed, because it's changing constantly. You can't get rid of these issues, but you can definitely mitigate these issues and make it much more maintainable. And that's what we're going to talk about today. I think the main takeaway of this talk is that test code is code. And a lot of people deal with test code as a second-class citizen, say, all right, I'm going to spend a lot of time on my code, and then if I get any chance, then I spend some time on my test code. The reality is that you have to maintain your test code the same way you maintain your code. So if you don't maintain your test code, you'll end up with a brittle suite of tests, which is not what you want. We all apply single responsibility principle in our code. And that's to make it more maintainable, to make it more readable. Why can't we apply the same thing on our test? It's the still code, and you still have to maintain it. The same is for do not repeat yourself. And the idea is that you have to care about your tests as much as you care about your code. Otherwise, you'll end up spending a lot of time maintaining them, and you may actually fail at that because you're spending too much time on your tests. So we're going to talk about how we can make a horrible test into an awesome test in 3 steps. And that's basically based on these ideas that you can apply anywhere. So we'll take a quick look at the sample that you've got. And again, that sample is from Selenium codebase, so you can download it from there. I'll just show you the sample here just to get an idea of what the sample is and the structure of the codebase. So this is the Selenium codebase here that we've got out of GitHub. You get a project here which is for the Selenium codebase, and there is a folder here called samples. We're using MVC Music Store, which is a relatively popular MVC sample which a lot of us are familiar with. And then there is also a functional test, MVC Music Store.functional test project, which includes all the functional tests for MVC Music Store. So I'm just going to be running MVC Music Store here to give you an idea of what it is, if you haven't seen it before. So basically, it's a website, an online website, a sample, that allows you to add a few musics to your cart and then a few albums to your cart, and allows you to purchase that. It's got a navigation bar on the top and navigation bar on the right. You can go to admin to log on if you have a user, or to register if you don't have a user. And in order to be able to purchase something, you would actually have to have logged on to the system. So with that in mind, just stop this guy here. And the functional test is also structured like this. So we've got a brittle test here. Can you guys see that clearly, or is it all right? OK, so we've got brittle tests here. Then we've got 4 folders, step 1, step 2, step 3, step 4. And those are the steps that I'm going to be taking you guys through. Each step builds on top of the previous one. So hopefully it's easy to follow. OK, so what's guaranteed to fail? A lot of developers are using tools that come with some sort of recorder, like Microsoft Coded UI Test, or Selenium in this case, which is what I'm using, comes with a recorder. You bring up the recorder, start recording, you take some actions, click a few places, type in some values, and then that tool allows you to export those actions into a script in your language of choice. So has anyone done this before? I've done it. So let's take a look at this sample first, see. And that's basically our brittle test. So if you take a look at this guy, that's exactly what's been exported out of Selenium IDE. And I've actually changed a few things here to make it more maintainable, just so it runs. So I'll just quickly run this guy. what it does, it just brings up the website and registers a new user, goes and adds a few albums to a cart, and then provides shipping information and submits the order. And the code is written by Homer J. Simpson. That explains why it's so brittle. It actually passes, and it took me a few runs to get it passed because it's really brittle. I'll take you through the code. So basically, if you look at the code, you can see that it's a series of calls into driver, and that driver is WebDriver, Selenium WebDriver. It goes through basically the same way that you recorded that test, goes through, clicks a few places, enters some information somewhere, and at the end, does some sort of assertion. Can anyone here see any issue with this code? Do you see any problem? Well, how many problems do you see with this code?
What happens if any of the IDs change on any of these labels or text boxes?
Yeah. So this is just one test, but the problem is that you're not going to be registering only one test. You're going to be registering in a lot of tests. So if the username ID or the first name, last name, or something changes, you're going to end up with a lot of broken tests, and you're going to have to change a lot of places where that's broken. The other problem with this is that it's very procedural. You can't really make sense of what's going on there. There is no modularity between the actions that the script is taking. So it's very hard to make sense of it, which makes it not very readable and hard to maintain. So in a nutshell, it's very procedural, which sucks. There is a fair bit of duplicated logic, and by logic, I mean in order to log onto the system or in order to register, we're taking a few actions there. And if that flow changes, is it okay if I close this door to avoid the noise? Hope it doesn't get too warm in here. So if that logic changes, you'll end up with a lot of broken tests, and you'll have to change that flow in a lot of your tests. The other thing is duplicated selectors. And selectors are things that automated UI testing frameworks use to select elements on the page so you can take action on them. Again, if you look at this guy here, you can see that there are a lot of duplicated selectors. Like the first name is duplicated twice in this code, but then you'll end up repeating this chunk of code in a lot of places, which means you've got a lot of duplication going on there. I'll do something else, actually. Yeah, while that's coming up. The other problem with this is that there is a fair bit of magic string, which is what you mentioned. If you've got a magic string in your code, you've got broken code. And the same happens for your test. If that string changes, you'll end up with a lot of broken tests. Hope it's not too big now. Yeah, it should be all right. Is it better now?
Yes, much better.
OK. So, and we've got magic strings, of course. So step one is to dry our test, and that is to avoid any duplication. Dry is do not repeat yourself, if you're not familiar with. And we're going to be using a pattern called page object for that. Page object is a pattern born in Selenium community. And what it does, it brings object orientation to your test. And that makes me really happy, because you can take those chunk of code into their own modules. That avoids the duplication that you've got there for the logic and for the selectors. So if something changes, you've got only one place to change. You'll typically end up with one page object per page under test. So if you've got a logon page, you'll have a logon page object. The beauty of page object is that if you've got a link on your page, that link turns into a method on your page object, which means that if you want to click on that link, instead of clicking on that link, you call that method, and that takes the action. So something like this that we had before, like find that element on the driver by the text admin and then click on it, turns into something like this. Application.homepage, on the homepage, call this method. Go to admin for anonymous user. So now if that logic changes, or if that selector changes, or anything changes there, you've only got one place to change. Likewise, a text box turns into a property, a string property on your page object. So if you want to fill in some values in a text box, you just set that string property, as easy as that. And if you want to get it, if you want to get the value, read the value out of that text box, it's a getter property. You just get that value out of that text box.
Wouldn't that ignore the effect that JavaScript may have on the page?
What do you mean?
Like clicking on an object that JavaScript could have hidden, but in code behind, it's still possible to call it, of course, because
Well,
your test
what
passes.
what the page object does, it only abstracts, it only encapsulates the logic that you would have otherwise had in your test script. So it's not creating anything magical there. You've got your Selenium test script and Selenium selectors. All it does, it extracts those out, put it into a page object that you can call from anywhere. Selenium, of course, if your link is invisible, it won't call it. It says, I can't find it, so I can't click on it.
Okay, so it's still the same code, just moving.
Yes, yeah, I'll show you that in a second. So instead of having something like this, where you fill in the email box with Homer Simpson's email address, you can do registerpage.email equals something. And what that does, it just sets the focus on that and fills in the value. Well, of course, that depends on your implementation of that property. Likewise, a checkbox turns into a bool property. You can tick and untick a checkbox by setting that bool property. And the other thing that I really like about page object is that any action, which is a clicking on a link or submitting a form on a page object, is a method on a page, is a method on the page object. And it returns another page object. So when you click on the link, on the admin link on the page, it takes you to the logon page. When you call that go to admin for anonymous user, it returns the logon page object. So that allows you to chain your code, which is really nice. So here I'll say on the home page, it returns me to the home page. Then I can call go to admin for anonymous user, which takes me to the logon page. From there, go to register page, and then set some properties to fill in the form, submit registration, takes me back to the home page, and this is dying. And at the end, I place order. I'll take a quick look at this guy here in the code. So that's step one. In each step, we've got the class that represents the code, and also there is a text file next to it which explains what the pattern is that we're following here and what the benefit of following that pattern is. So on the page object, that's what we've got now. We've got application.homepage. On the homepage, we call this method. And to answer your question, that's basically what we had before. Go and get, this is the exact same selector out of Selenium. We go and get that object and then navigate to another page. Now this page here is out of Selenium. Again, I'm using Selenium here, but you don't have to use Selenium or Selenium or any of the frameworks I'm using here. Just feel free to apply these patterns. They're quite platform agnostic on anything that you want. So there is a page object in the Selenium framework which exposes title and URL of the page. And that inherits from UI component, which exposes quite a few useful information there. One of them is navigation. It allows you to navigate to another page. So going back to the home page, clicking on this guy here, or calling this method, is clicking on a link by the text admin, which is exactly what we had before. If we go to our brittle test, that's basically this guy here. So the selector is exactly the same as before. And then we can use Selenium here to say, as the result of taking that action, navigate to the logon page. So on the code here, I can say that on the home page, call this method. Call this method that returns logon page. On the logon page, I've got another method, go to register page. From there, I go to register page. I've got a few properties there. They're only setters because I don't want to read the values that I entered before, and I want to abide by Yagni principle. I'm going to cover that later. And then at the end, I just submit my form. Again, this is exactly out of Selenium. This is the Selenium selector that I had before. So that turns my test into something like this, which is much more readable, much more maintainable. At least I know that my logic is abstracted and encapsulate it into one place. So if that logic changes or if that selector changes, there is only one place to change. Any questions about page object itself or the code that we just saw?
How do you step out here?
Beg,
Step out here?
beg pardon?
So we're going 4 steps. First
That
step.
was just first step, yeah.
How did you create that page object? How did you create it?
That's just, so if we go back to the code and have a look at the brittle test, so we've got these chunks of code that when you look at it, this is to go to the admin page. So you can, basically what I did here was to record these actions, which is not what I usually do, but for this demo, I recorded these actions, then I extracted these bits of logic out of this huge brittle test script, put them into objects that represents those pages that were under
So
test.
you manually created that.
Yes, yeah. There is no code generation there, yeah.
Small question. Do you think it would be worth to do some extra work to an additional step to get the IDs directly from the code, so we do not even change, we do not even need to change it in one place, but get it directly from the original?
Yeah, we'll get there as one of the steps. Bear with me. It's coming up next. So step 2 is to use page components. And you can use page components to compose your page objects of smaller bits and pieces. Forget about testing altogether. Some of the pages on our website are big. Some of the pages are very complex. And if you're following single responsibility principle in your code, you wouldn't end up with a big and complex class or page or whatever in your code, right? You wouldn't, if you're using ASP.NET MVC and Razor, you wouldn't end up having a view CS/HTML file that includes 600 lines of code. You would extract those information out, put them into page components or user controls or partial views or whatever you call it in your UI technology of choice, and then reuse those bits elsewhere as well. Or the other benefit is that if something changes, you've got one place, one modular small place that you can change. And the same goes for your test. You have to care about it as the same. So if you've got big and complex page objects, then you're perhaps doing something wrong. Break it down using page components. And page component is another pattern which is exactly the same as page object, except that it only contains a small component of your system. You can use page components for a lot of things on your page. If you've got a panel on your page, you can turn that panel into a page component. If you've got grids, and this is my favorite one, if you've got a grid of rows, you can have a page component for that grid. And even more nicely, you can have a page component for a row in that grid. So instead of writing a huge complex selector with CSS or XPath to go and get the second column of the second row and extract the value out of it, you turn that row into a page component and call it row in that grid, blah. And then you return a property, an IEnumerable property of those page components. So if you want to access the second column, you can use link and say, skip the first one, get the first one. And that gets you the second row in that grid. You can use it for modal pop-ups. You can use it for menus. You can use it for any bit of information that you want to extract and put it into a page component. Think of it as a code. Like out of the box with ASP.NET MVC, we've got logon partial, which is that thing on the top right corner of your page, which only includes logon information and links and whatever. Just extract that out, put it into a page component so you care about your tests in the same way. I can see that a few of you guys are actually taking screenshots of this. This is the code, and the slides and everything is available from my blog. I'll show you a link at the very end. Feel free to take screenshots if you want, but page components draw your tests even more because I'll show you an example of that in a second. So you know how we had this, and I mentioned that we got rid of duplicate logic and duplicate selector, but that's not quite right because you know how we ended up putting that method on the home page? The reality is that that admin link is not only on the home page. That's on the navigation bar on the top, which means that you're going to have that on every single page of your application. So we still have some duplicate logic and duplicate code there because if you want to log on or if you want to go to admin from any other page in the system, in your test, you would have to duplicate that bit of selector and that bit of logic in there as well. So instead of that, you can have something like this. Admin on the home page, go to the menu page component, which represents the menu bar on the top, and on there, click on that, on there, call that method. And the beauty of that is that, firstly, your page components are not going to be big and complex. But the better thing about this idea is that, as mentioned before, that navigation bar is not only on one page, it's in a lot of pages. So you can compose other pages of these smaller bits and pieces. So home page will end up looking something like this. And we are using two components there, navigation component and genre component. So step 2 is page object with components. Again, this is exactly the same as step 1. The only difference here is that go to admin for anonymous user is not on the home page itself. It's on a menu component, a navigation component. And this navigation component is used on the home page for this sample. And if I was using it in different places, I could have just used it in other pages as well. So home page, while the home page in step 1 had the logic, the selector, and everything to go to that admin link, now it only exposes the menu on the top and the menu on the side as properties. I'm again using Selenium for this code, and it uses a method on the page called getComponent, which resolves your component through an IOC container. But the idea and the pattern is the same. You just use a component to break down your big pages, and you can reuse those components elsewhere. So using page objects and page components, we can get a single responsibility principle in our test. And we can dry our tests really well. But there is still a problem with that, which my friend mentioned, and that is magic string. We still have a lot of magic strings in our test code. And that means that we're going to have broken code everywhere. So this is register page from step 1, and that's the same for step 2. And we can see that username, email, confirm, password, all these are magic strings out of our pages. So if you go and change username, still, you're going to end up with a lot of broken tests. But the benefit of having page object is that you only have one place to fix. But that doesn't mean that you'll have less broken tests. You're still going to have a lot of tests that are broken. And that is everything that uses register page. But the problem I've got with this code is not just about magic string. I've got another problem, and that is the code is ugly. Earlier, we mentioned that we can get API chaining through using page object. But that chain is broken here, see? I go to register page, the chain is broken. I have to set some properties, and then I have to call a method there. That API chaining is broken there, and I don't quite like that. I thought to myself, as I was doing this sample, I thought maybe to kind of gain that API chaining, what I can do is I can pass those arguments inside the submit registration method. And then I thought to myself, all right, so I've got 4 string properties that I'm injecting into a method. Not necessarily very readable. I'm promoting readability of the test code. And injecting 4 string parameters into a method is not necessarily readable. I thought, oh, hell, that's only 4 properties, only 4 arguments. That's OK. So I was going to do it, and then I saw this other guy. These are 10 properties they're set, and I really don't want to inject 10 properties into a method because that's not going to make any sense to the person who's reading that. So what's the first one? Well, OK, you know who Homer Simpson is, and that's first name, last name. But in a typical test, you wouldn't be able to make sense or differentiate the differentiates the parameter. Step 3 is strongly typed page objects. So what would we do in our code if we had something like this? There is a pattern called parameter object, and that is to create a property bag, which you can use to set up these properties on. So you set these properties on a property bag object, and then you inject that property or pass that object into your method, right? So why don't we do the same for our test? After all, our tests are our code as well. So we'll use strongly typed page objects. But I don't want to create new objects in my test because that's going to be duplication as well. We're going to get rid of that duplication as well. We're using view models in our code, right? So that's out of the code base. The register action method on the account controller is taking in a register model, and that's a C# object. that object is used to inject these, to kind of bind the form post values that's passed to the action method. And they're also used to generate IDs of the field that are on the page. So we can just reuse the same thing on our test as well. And that's the result of that. That's the entire code for the brittle test that we had before. And now we've also gained complete API chaining. I'll quickly show you what I've got there. Step 3, strongly typed page object with components. And that's my entire test. So far, we only had up to step 3. We had made it this far. But the problem I had, as I mentioned before, was that I had broken that API in the middle. I had broken that link. But now I'm using this method here that creates a valid user, which is pretty much the same as what we had before, this submit registration. It's pretty much the same method, except that I'm passing the values I want that form to use to populate the properties and submit the form. Let's take a look at this guy. What is it? That's the entire code for that, actually. I'm using fill with model, which is a method out of, I'll take a step back. This class, register page, is inheriting from a generic page out of Selenium. And this generic page is inheriting from UI component. And that's got a few goodness in there. One of them is fill with model. You just pass it a view model that you're using in your code. And what it does, it iterates over the properties on that view model, uses the very same logic that ASP.NET MVC uses to generate the unique IDs that you use on your page. And if you guys have had a look at the ASP.NET MVC, it uses expression helper. I don't know if you can see that there. So this class is actually out of ASP.NET MVC. And ASP.NET MVC uses expression helper to generate unique IDs for the elements that it puts on the page. So we're reusing the same infrastructure that MVC uses to generate the IDs of your elements on your page. So what you do here, if you want to create a valid user, this register model is a view model that the website is using. I don't know why that's happening. So any property that you put, any data annotation property that you put on your view model, anything that ASP.NET MVC can make sense of and will use to generate unique IDs for your elements on the page is going to be reused by Selenium because it's using the very same infrastructure. So I'm passing this parameter object to my create valid user, and Selenium is populating the values by using this fill with model, and it's calling the same thing. So by doing this, I achieved a few things. One is I've got nice API chaining that you can make sense of. So when you read this test, or the next developer who takes over you and wants to maintain this test knows that this test on the application, on the home page, on the menu of the home page, clicks on that guy, from that page, clicks on the register page, creates a valid user, which takes it back to the home page, goes to genre menu, selects this genre, select that album out of that genre, adds it to the cart, checkout, submit shipping info, and the title of the result page should be checkout complete. So it's much more maintainable now, and we've gotten rid of the issues that we had in the middle where the chaining was broken. And also, we've gotten rid of the magic string, because if the username changes, what is username? Or how do you change username on your ASP.NET MVC website? Do you go and change the text on your CS HTML page? Hopefully not. Hopefully you're using some HTML helper that knows how to turn a property of your view model into an element. If you're using that, we're using the same infrastructure to generate those IDs. So we iterate through these, and we can find out what the property name is, and then filling those properties with the values that you provided inside the register model. So I mentioned that there's going to be 3 steps to make our test more maintainable, and there were 3 steps there, and the test that we've got is as maintainable as it can get. You've gotten rid of all the issues that an unmaintainable test could have. But we're going to take an additional step, step 4, and turn those also maintainable tests into something better, or not maybe better, but get more value out of those tests, those maintainable tests. And that is to generate living documentation for our system. What we can do, we can get the code to generate the documentation of the system. So if you change your code, your documentation changes. If you're using Agile, or if you're not using Agile but using some sort of user stories, or if you don't have user stories but have got some sort of acceptance criteria of the features that you're working on, you can write your UI test based on those acceptance criteria. And you can use the BDD framework to implement that acceptance criteria, and hopefully that BDD framework generates some sort of documentation for you. And that means that when you change your test, you're going to get a documentation that matches your test. You don't have to waste that much effort trying to really hard to sync your code with your documentation and fail at the end. So I've used BDD5 for this sample. Don't have to use BDD5. There is plenty of frameworks out there that allow you to do that. But just that I feel more comfortable with this one. So this is my test. Admittedly, it has, or it looks bigger than the step 4 that we had before, because there is a little bit more in there. But thing is that everything that you see here is just the bits that we had before extracted and put into a method that kind of explains what those actions are doing. So these few methods up here says, given that I'm a logged in user, doesn't matter what a logged in user means in our test. If you call that method, you'll end up with a logged in user in your test when the test is running. And if you want to add an album to your cards, you can call this method and it adds the album to your card. So it's basically the same amount of code, but extracted and put into smaller chunks so you can maintain them easier. I guess we're running a bit out of time here. So what it does is that it runs the same amount of code, and that's the only API that you have to do, and you can extract it and put it into a base class and never see this again. When you run this guy, you'll get a report that explains what steps you've taken. It's basically the same thing. I'm not going to waste your time by letting you watch that. Just runs through the same. Oh, OK. Selenium is going to make you watch that. So the beauty of that is that you can use the test result as a progress report. So as you're coding your test, or as you're coding your scenarios and stories, you turn those steps in your documentation green. So if you provide those reports to your business, they know that, all right, they're implementing this feature, and they're this much through that feature, because those lights are turned green as you're implementing those. The other thing that I find very useful is that you can use the test result as the supporting for your manual testing, because you don't want your manual testers and QA team to go through the same things that you're already covering through automated UI tests. So you just provide them with that report, and they know what's covered, and they test what's not covered, and do more exploratory testing and creative testing. Anyway, that test hopefully has finished. At the end, it gives you this report that says, this is the story I'm implementing. If you're doing a story, otherwise it wouldn't show you that. And this is the scenario that given I'm a logged in user and I'm blah, 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 blah. So that's a text report, the console report that you can use as a developer. But to communicate that to your business, it also gives you an HTML report that you can provide to your business. And as you're implementing your logic, it actually shows you that these lights turn green. So if you hadn't implemented your when I check out, it would show an orange light next to it that this has not been implemented. So you can use this report to communicate the progress of your team to your business. OK, the main part of it is done. We're going to start going through some tips, and I've got like 15 minutes. The main tip, the first tip, is that do not use thread sleep. If you're using thread sleep, there is a very, very good chance that you're doing something wrong. There are a few issues with that. One is thread sleep is slow. Why is it slow? I have to wait this much for this code to load anyway, so I'm putting this thread sleep. It's not going to be any slower. It is going to be slower for a reason, and that is maybe this step or for this page to load, it always loads in, 200 milliseconds. But sometimes when the network's slow or your database is overloaded, it takes 10 seconds to load. So you don't want to end up with broken tests. So you're going to say, all right, I'm going to put a thread sleep there for 5 seconds to make sure that this step is always going to pass, which means that in 95% of cases, you're going to have to wait 5 seconds more, even though that page or that element has already loaded. That's going to make your UI test very slow. UI test is slow by default. Don't make it slower. And you say, all right, I'm going to apply 80-20 rules there. I know that in 80% of cases, this page is going to take less than 2 seconds to run or load, and in 20% it's going to take maybe 5 seconds to run. So what I'm going to do, I'm going to put a thread sleep of not 5 seconds, but of 2 seconds to make sure that in 80% of cases my test passes. So that makes your test brittle, because although in 80% of your cases it's going to pass, in 20% it's going to fail because the page took longer to load. So if you often need to wait a bit longer for something on your page to load or for your page to load, out of Selenium you can use implicit waits. And I'm pretty sure this is available on every single UI testing framework. So what it does, it says, and this is a global setting, it says wait that much up to that long for an element or for a page to load. So you can say set implicit timeout once in the beginning of your test to 10 seconds. That means that Selenium is going to poll every 500 milliseconds by default to say, all right, when the page loads up, is the element there yet? No, it's not. Wait. Is it there? No, it's not. Is it there? Yes, it's there. It comes back. So if the element is loaded after 200 milliseconds, you get instant feedback from this. If it's loaded after 5 seconds, it waits for 5 seconds, which means that it's not going to wait longer than it needs for that element to load. But some of the elements on the page or some of the pages are slower. Like you may have to make a call to a service or third-party server there. That's always slow because they're doing some crazy queries. Or maybe you have to populate the view based on the page based on a view that is slow. So you have to wait maybe a bit longer for specific elements or for specific pages to load. For that, you can use explicit waits. Again, that's out of Selenium, but it's wrapped in Selenium. What you can do, you can say that, all right, globally wait up to 10 seconds for elements to load. But for this particular case, you're allowed to wait for 15 seconds. Again, if the element is loaded after 200 milliseconds, the call is going to call back after 200 milliseconds. But that's not all. Maybe sometimes you need to wait for an AJAX call to finish, and you don't really want to use a thread sleep. What you can do for AJAX in particular is that in Selenium, we've implemented this method that uses jQuery and checks the browser to see if there is any active AJAX calls going on. So if you call this guy, wait for AJAX call to finish, it waits up to that timeout for the AJAX call to finish. If it's finished, it returns instantly. If it's not finished, it waits up to that timeout and then crashes or throws an exception. Tip 2, choose right selectors. And this is really important, and I've seen a lot of teams make this mistake. The problem is that page structure changes. And a lot of developers are fuzzy about their selectors. They use the structure of your the structure of their page to find an element. Like go to this grid inside this div, and then inside that div on the third row, on the second column, find that. And there is a nested anchor in that. I want the value out of that anchor. Well, that structure is going to change. That doesn't necessarily mean that your test should break, because the logic is the same. Everything is the same. You've only changed the structure of a page. Don't rely on the surrounding element of something to say that that element exists, exactly for the same reason. So XPath is a very good example of that, and I've seen things like this a lot. This is just bad. This is going to break. In our code, we use a lot of interfaces. We use dependency injection. We use a lot of patterns to make our code more unit testable. And UI test is just test. So give it the support that it needs. If you're putting that much effort to make our code more unit testable, maybe we can spend a little bit effort into our UI test as well. Yeah, that's okay. Add an ID to your page that's used nowhere except from your UI test. What's wrong with it? You've got an ID there that no one uses except your UI test. At least your UI test is not going to break. That's okay. Next tip, only one test per action. What time is it now? I made this mistake a while back. We had a large workflow in our system, and what we did, we said, all right, this workflow has got 15 steps. I'm going to test step 1, and then I'm going to test step 1 and 2, then I'm going to test step 1, 2, 3, I'm going to test step 1, 2, 3, 4. That's not good, because I was using the UI to set up the state to test step 4 or to test step 6 or whatever. That's not good for a few reasons. What you can do, you can use one test to test, one UI test to test each page in isolation, and then you can use one test for the entire flow to make sure that you can actually connect your pages and connect different steps in your page. If you set your steps through UI, you're going to end up with a few issues. One is that's slow, because to get to the 15th step, you would have to go through 14 steps. And UI testing is slow, running UI is slow. So you're going to end up with a slow test suite. And it's also going to be brittle. If your step 2 is broken, but step 4 and every other step in your workflow is correct, you don't want to end up with 20 broken tests just because step 2 is broken. Write a test for step 2 and one for step 3 in isolation. If step 2 is broken, you'll end up only with one broken test, and you know exactly where it's broken, what's broken and where. So how do you set up your state? You can set up your state not through UI, but through code. If you're using some sort of ORM, definitely you can go through your code and call the same methods, perhaps, that your UI would have called otherwise, and set up your state. So how can you go to that page? You can go to that page directly by navigating to it. Well, we're here using MVC out of Selenium. We say, on the account controller, call the register action method and return register page. But you can navigate to the same page using URL or whatever. The problem is that URLs are a bit more brittle. Do you guys have many questions? I wonder whether I should skip these few tips and leave some time for Q&A, or if you've got any questions, just try me. Otherwise, I'll just continue with this. Design by interface, and that's not something that's used or needed by a lot of teams, but if it's needed, it's very useful and important. Do you support multiple devices? Like, do you support your website, different views or different variations of your website for iPad, iPhone, tablet, whatever, PC? If you're doing that, then you would end up with different page objects and different test scripts to test your pages, different variations. Do you do A/B testing? Do you target different groups of people with different variations of your page? The same thing applies. What you can do, you can create interfaces for your page objects, and instead of using the concrete type, you can use the interfaces to test. And that means that you can use, well, for something like this. If you've got some page, you've got an interface called iSomePage, and then you have different implementations of that interface, and as many implementation as you have for your A/B testing or whatever. And then you have one test script that only relies and depends on that interface. And then you can run one test script that tests your entire website with different variations. Next tip, you ain't gonna need it. You ain't gonna need it in your code, and you ain't gonna need it in your test code. Don't create page objects if you don't need it. Just because you created this page doesn't mean that you should go and straight away create a page object for it. If you're testing that page object in one place, doesn't mean that you have to go and create every single link to that page object. If you add a property to your page object, only add it when you need it, not because that property is on the page. If you add a property, don't add the getter, because a lot of cases you don't need to get a value out of your property. Like in the registration page, I only ever need to register. I never go back to that registration page in read-only mode. If I want to change my username, it's a different page object, different set of properties. This is for any test, not just UI tests. Run and maintain your tests. If you don't run your tests frequently, you're going to end up with broken tests. And if you don't run them frequently enough, you don't know what broke those tests. So it's going to be really hard to maintain them. Fix your tests as soon as they break. Run your tests frequently and fix them when they break. If you don't run them, you'll end up with broken tests. And if you don't fix your broken tests, you'll end up with a set of ignored tests that you'll delete after a while. And finally, my good friend Confucius says that UI testing is hard and could be a lot of wasted time and wasted effort. So either don't do it or do it right. When done right, it's well worth it. you.